In this problem, we're going to solve an equation that's quadratic in form. We'd like to solve the equation x to the fourth plus x squared equals 3x squared plus 8. I'm going to solve this algebraically in the real number system, and we want our answers to be exact. We're going to start by moving all the terms to the left side of the equation, so that the right side will be 0. So we'll have x to the fourth. If we subtract 3x squared from both sides, we'll have x squared minus 3x squared, which is minus 2x squared. And we subtract 8, so we'll have minus 8 is equal to 0. And we'll recognize that this is quadratic in form. If we do a substitution and let u equal x squared, we can rewrite this equation in terms of u. If we think of x to the fourth as x squared squared, then minus 2 times x squared minus 8 equals 0. And since we're letting u equal x squared, we can write this as u squared minus 2 times u minus 8 is equal to 0. Now here we have a quadratic equation that we need to solve that's quadratic in u. We solve this by factoring. Get u minus 4 times u plus 2 is equal to 0. We set each of these factors equal to 0. U minus 4 equals 0. U plus 2 equal to 0. And we solve these two linear equations. We'll get u is equal to 4. And u is equal to negative 2. Now the original problem is in terms of x. We need to go back in terms of x. We said that u is equal to x squared. So we really need to solve x squared is equal to 4. Or x squared is equal to negative 2. Take the square root of both sides. We'll get x is equal to plus or minus 2. Or x is equal to plus or minus the square root of negative 2. Now the problem asked us to solve this in the real number system. The square root of negative 2 is not a real number, so we exclude those solutions from our solution set. That leaves us with just x equals plus or minus 2, so our solution set is negative 2, 2.